Hello again YouTube, and welcome to another episode of X-Ray Tech, giving you an inside look at PC hardware. Today is going to be a focus on hardware performance in the new Battle Royale game that's taken the crown previously held by Fortnite, Apex Legends. First, this game is set in the Titanfall universe. I'm going to be referencing Titanfall 1 and 2 as well as comparing Apex Legends to it directly, so if you aren't familiar with these games, give them a look. There's plenty of reference material on the web. Diving right in, I will say that the first and second games have set the groundwork for excellent, fast-paced shooting action with fluid combat. They integrated both infantry and heavy armor on the same battlefield, with armor taking the form of towering titans. So, Apex Legends is set in this universe. The gameplay revolves around a deathmatch played with teams of 3, a feature that sets this game apart from popular BR titles that it competes with. Instead of playing the overpowered and versatile pilots of the Titanfall games, you play as more realistically talented fighters that bring their own unique skills to the table. Titans themselves are not a feature of Apex, but an entire arsenal of familiar weapons from the first and second games are back. I have to say, Apex delivers the same rewarding combat and feel that Titanfall did. While the verticality and parkour stunts of the pilots are limited with these characters, I honestly overall feel like I'm playing Titanfall. In my eyes, this is a good thing. Titanfall played really well. There are now 9 different characters to choose from in Apex, each with strengths and weaknesses brought to the table. Unique character abilities, if used right, greatly benefit the team as a whole, while somehow not resulting in overpowering the character. No character skill will truly protect you forever from a foe's well-aimed shots. I think personally this highlights one of the strongest virtues of this game, that it rewards skill, situational awareness, and proper use of one's surroundings while fielding these unique character abilities. While Apex Legends is the focus of this video, I won't be diving any further into advice on meta for the game or how to play. It's free. I highly encourage you to go check it out for yourself and develop your own opinion. One thing I am absolutely certain of, however, is that Apex Legends is here to stay, not only judging by the way that the community has picked it up, but also by how the developers are supporting it with regular release of content in the form of weapons, characters, and I assume at some point soon, maps. Anyway, I don't know if I've mentioned it, I'm really pumped up to bring this one to you because I pulled out all the stops. Every graphics card that I own that can support this game at over 60 FPS at 1080p has been pulled out. Our test bed is our trusty X58 test system with a Xeon X5650 overclocked to 4 GHz and paired with 24 GB of G.Skill Sniper DDR3 1600 memory, running of course in triple channel. Now without any further ado, let's get to the benchmarks. So, jumping into testing, everything is done at a sort of medium settings, as far as we can get it given some of the interesting graphical choices we have available to us. We'll go into that just a bit later in the video. Keep in mind that Apex Legends does have an FPS cap of 144. We'll start with the AMD graphics cards, and the R9 380 is at the bottom of the lineup, coming in at 68 FPS. Following it is the oldest card in our lineup, the HD 7970. This card took the average FPS in the game up to 75 for a roughly 10% increase in performance over the 380. The R9 390 handily beats it at 98 average FPS, which is beaten only slightly by the R9 290X at 101. Newer cards will begin to show with the RX 474GB just edging it out at 104 FPS, and the RX 484GB does a bit better at 112. But this is where we start to notice a trend that I'll point out at the end. The R9 Fury X with its HBM memory should have a fair lead over the 480, but instead the two come with a margin of error of one another, with the Fury at 113 FPS. Vega 56 and 64 followed up with an equal scoring of 122, a phenomenon explained by one of two possibilities. The 56 is a Power Color Red Devil card with infinitely better cooling, and the 64 is a reference card that couldn't ramp up to its maximum performance potential. Or we're hitting a bottleneck elsewhere in the system, either in regards to memory or processor speed. This is something that we'll put on the shelf for another video, but because now it's time to cover the NVIDIA cards. The GTX 780 starts us off with 66 FPS, followed by the 1050 Ti at 67. The 980 brings up a disappointing 69 FPS, and the newer 1063GB handily beats it, which is confusing at best. The 1063GB puts up 83 FPS, followed finally by the venerable 980 Ti at 103. We can extrapolate several trends from this list. 1. This game clearly favors AMD graphics cards. There's no way that an HD 7970 with the same amount of VRAM at the same settings should score 15% higher than a GTX 780. Similarly, the GTX 980 should be able to soundly defeat all of the AMD cards up to the Vega 56, instead falling into the realm of competitiveness with the worst AMD card on the list, the R9 380. Furthermore, we see another trend emerge, one that shows the game's favor for optimization towards recent GPU architectures. There's no way that a GTX 980 loses to a GTX 1063GB unless Maxwell is not really taken into consideration for optimization of the game in general. Likewise, there's no way an R9 290X should score evenly to an RX 470 4GB. Now, there were 3 more graphics cards in my collection that could handle Apex at 1080p and still return a 60 FPS average, but all 3 of these cards have only 2GB of VRAM or were inherently not up to the task of handling the load of our medium settings set up from earlier. This small segment shows you the performance of these cards with everything turned down to the lowest setting except for our texture streaming budget, which stayed at 2GB. The R9 270X puts up a fight with 65 FPS, followed by the 660 Ti at 62, and the GTX 770 at 70 average FPS. Now, for those of you out there looking to reproduce your own data and do your own testing on this game, a factor that comes into play is that whenever you're out there in the game and you come up against a wall and that wall takes up part of your viewing space, you're going to get a boost in FPS. You're going to get a significant boost, as you can see here. Just looking at this map brings me all the way up to the game's max of 144, and looking away at wide open spaces drops me to about 110. Finally, wrapping things up, we're going to go ahead and look at the settings. You see some pretty standard stuff here: resolution, aspect ratio. We're at 1080p, disabled VSync. Adaptive resolution is super interesting. Anytime your graphics card hits a load that's too high to keep it above your targeted FPS, it'll drop textures, but this comes with a huge trade-off. You lose the ability to really make out far away models and objects, to include characters, so keep that in mind when using adaptive resolution. We left TSA on. We used the medium 3GB setting to accommodate our 3GB graphics cards. The Anisotropic 4X was left in just to keep things nice and sharp. Ambient occlusion is one of the first things I turn off anytime I have something to give up to reduce graphics card load but don't want to reduce quality. Sun shadow coverage, sun shadow detail left on high, spot shadow details turned off, volumetric lighting and dynamic spot shadows are left on. And something to note, model detail would not apply at anything less than high. It always stayed on high. As we wrap things up, I've left a little bar graph here for you. Feel free to pause later and peruse the stats, which also includes the 1% low values. We learned a couple things from this video, which is that in this specific testing scenario, Apex really seemed to prefer AMD graphics cards, enough so that some older NVIDIA cards that should have destroyed this game actually lost to AMD cards several tiers of performance below them. Within this preference on both AMD and NVIDIA sides, we also saw a lean towards newer architectures, specifically Pascal, Polaris, and Vega versus their predecessors. For example, the GTX 980, a Maxwell-based card, scored 69 FPS against the GTX 1063GB at 83 FPS. The GTX 980 is a more powerful card with access to an additional gigabyte of VRAM, and it honestly should have been the other way around. We can also observe that the game was not necessarily CPU bound, as the majority of testing had CPU usage at around 50% on a single core at any given time. Considering that the X5650, while respectable, is not by any means a new CPU, means we can generally assume Apex is forgiving of users that don't have the best money can buy. Anyway, I really hope you enjoyed this video. I had a ton of fun bringing it to you, and I'm very much hooked on Apex Legends. If you found this video helpful or informative, please leave a like, comment, or subscribe. If you didn't, feel free to dislike and leave a comment as to what way I could improve the channel for you.